All right, so let's talk a little bit more about the tests and also p-values. So after you've stated the null and alternative hypotheses, and you specify the level of significance. So again, this is a choice for the researcher to choose a good level of significance for that situation. The next step is to actually obtain a random sample from the population and calculate the sample statistic. So are you looking at means? Are you looking at proportions? Are you looking at variances? The sample statistic is called the test statistic with the assumption that the null hypothesis is true. The test statistic is then converted to a standardized test statistic. So again, typically for our class, we're going to use Z or T. This is called chi-square. So we're not going to get to this in our class, but you will see it in the text in later sections. And as we said before, when we did our confidence intervals in the last section, the Z and T values we used a lot, we're going to do the same thing here. And that standardized test is used in making a decision about the null hypothesis. And I know this all seems pretty confusing right now. So right now we're just kind of going through the definitions, and then we're going to put the whole process together. So for our class, we're really just going to focus on means. So our population parameter, we're going to use mu for mean, and we're going to use the X bar for our test statistic. And then we're going to cover sections 7.2 and 7.3. So in 7.2, very similar to confidence intervals, we can use z-scores when sigma is known. And we're going to use t-values in 7.3 when sigma is unknown. So again, this is going to really mirror what we did with confidence intervals in chapter 6. We are going to skip proportions. So this is proportions. And variances in our class, okay? So it's very similar procedures for hypothesis testing with proportions or with variances. It's just that you're using different test statistics. So you're using Z's, but they're going to be based on the proportions instead. And here you're using what's called chi-square. It's spelled chi, but it's pronounced chi-square results. But again, we're going to skip these, but if you happen to see them in your research online or in articles that you're reading, they're just other ways to hypothesis test, but very similar steps, just different calculations. One way to decide whether to reject the null hypothesis is to determine whether the probability, so probability is coming back here, of obtaining the standardized test statistic is less than the significance level. And I'm going to show you two ways to hypothesis test in the next couple video chapters, really. But the p-value method tends to be a really popular one because we can use technology rather easily there. So I'll show you two different ways you can test, but the p-value again tends to be very popular. So if the null hypothesis is true, then the p-value, which is a probability of the hypothesis test, is a probability of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. Now, this doesn't make too much sense right now, but your p-value is just a probability. So we're basically going to say, all right, if that probability is very small, then it's going to be unusual and very weird, right? So then the null hypothesis must have been false. And if the probability is quite large, then we're going to say, okay, that seems that the null hypothesis was true. So we're going to use that probability and that idea of if it's too small, it being unusual, and if it's large enough, it being fine. Your p-value does depend on which type of test you are doing. So we have left-tail test, right-tail test, and two-tail test. And sorry, a typo here. The type of tests depend on the location of the region of the sampling distribution according to the rejection region of the null hypothesis. Now, this rejection region is actually indicated by the alternative hypothesis. So that's actually the one that's going to tell you which type of test to use. And it's much easier than it sounds. So if the alternative hypothesis contains the less than symbol, you are doing a left tail test automatically. And what happens is your P area is to the left of your test statistic. So whatever your test statistic is, your p-value area is here. So this is going to be the probability that we're looking for, is this area. So kind of very similar to chapter 5. If your alternative hypothesis has a greater than symbol, so again, it's the alternative hypothesis, just be careful here, then you're going to use a right-tailed test. So the area that we're looking for under our curve is going to be on the right side. Now, a two-tailed test is used if you have a not equal sign, so I know it's hard to see, not equal sign in the alternative hypothesis. So basically what's going to happen here is you're going to have like half your area is going to be here, and the other half of your area is going to be here. So it's two-tailed, meaning it's on both sides. And each has half the probability. So you're going to find both areas, add them up together. So it should be just, they should be the same on both sides. So you're just going to double one of them. And that's going to be your probability in that case. The smaller the p-value of the test, the more evidence there is to reject the null hypothesis. So your p-value is just a probability. So if that probability is very, very small, that's unusual. It's not likely to happen. So we must have made a mistake on the null hypothesis, is what it's saying. Also, just remember that there's always a chance for error. So even if the p-value is very, very low, it's not 100% proving the null hypothesis is false. It's only probably false. So again, just keep in mind that just like with confidence intervals, where we kind of said like, oh, we're 95% confident that the mean occurs here. It's the same thing with hypothesis testing. So when we use an alpha of 0.05, we're basically saying we're 95% confident in our results. So it's a very similar idea. All right, let's do an example here. So for each claim, we're going to state the null and alternative hypotheses in words and in symbols, and then determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed. And we can also sketch the normal sampling distribution and shade the area for the p-value here. So for the first one, we've seen this before. So a school publicizes that the proportion of its students who are involved in at least one extracurricular is 61%. So we have already seen this one. So the claim we already saw was that the proportion is, so equals 61%. And we saw that because there is equality there, oops, let's put dots here. Our null hypothesis is the equality piece, and our alternative hypothesis was not equals, right? That was the exact opposite. So when I'm determining my type of test, I'm using this symbol here. So it's always the alternative. Because this is a not equals, then we have a two-tailed test. So your graph, using our normal curves here, is basically saying that we're going to have some probability this way and some probability that way. So we have probability here, and we're going to add those together. And this here is going to be our whatever our test statistic is. And I haven't told you guys yet how to calculate this. Now, because everything is symmetric, it's going to be the same on both sides, so the same probability. So you should, when you add them together, just get a doubling here. So for this one, a car dealership announces that the mean time for an oil change is less than 15 minutes. So we saw that the mean is less than 15. Oh, messing up my notation here. H sub 0 and then H sub A. So because it's a strict less than, it's going to be our alternative hypothesis. And that means our null would be the opposite of that. And again, it has to contain equality. When you're determining the type of test to use, you look at your alternative hypothesis. So a less than symbol, that you're using a left-tailed test. So what happens in the picture is that our probability is going to be on the left here. And remember, this probability is your p-value. And then finally for C, the claim was that a company advertises that the mean life of its furnace is more than 18 years. Because it's greater than, we're going to put it as the alternative, and then the opposite would be less than or equal to for the null. And again, for the type of test, you're using the alternative. So that symbol is pointing to the right. We're going to use a right-tailed test. So your picture looks like this. Okay, and that p-value we're going to find is just our probability.